This hot water system belongs to my neighbor, and now we see how I transformed his system over the past 2 years to improve its efficiency and compactness. Our system consists only of this set of solar heaters and this hot water tank, which is surrounded by thermal insulation with a thickness of 5 cm. So, the system does not have a pump, automatics or other equipment, and for example, now the water of the tank is already heated by the solar heaters to a temperature of almost 55 degrees Celsius. These solar heaters are also interesting for heating water of a pool, but an ordinary pool requires several tens of times more heaters than we see now. So, this hot water system was part of my research on the idea of combining solar heaters with traditional coatings of a house or building, similar to this idea of installing solar panels instead of traditional roofing. For example, a similar set of solar heaters can replace such external wood blinds. Or we can use our heaters instead of similar structures which are designed to protect from the sun. In addition, our heaters can replace such transparent walls. Also, our set of heaters can be used instead of similar fences. Now I am showing one of our solar heaters, and this is a thin steel sheet which will be coated with cheap black paint. Therefore, the sun heats the sheet and it transfers the heat to the water which moves through these pipes. Of course, we can use some other type of solar heaters, and now I show several alternatives which have already been tested by me, and I will describe them in my future videos. This is my experiments with addition of a cheap transparent film. It increased efficiency of the solar heaters and the temperature of the water heating, but only by a few degrees. However, it is obvious that the improvement in efficiency will be greater if the film is installed more carefully, or we use not the film but glass or cellular polycarbonate. Now I show other methods of improving the efficiency of the heaters, and this is an extra layer of thermal insulation on their hoses. This is a sheet of expanded polystyrene under the heater, and this is a cheap reflective film which gives extra solar radiation to the black surface of the heaters. The reflective film may be interesting if we correctly choose the tilt angle of the heaters and the height of the interval between them. Of course, this option of solar heaters with these mirrors increases the efficiency and the heating temperature radically more, and this curved mirror option is even more efficient. However, I will describe these two mirror options in my future videos, and the topic of this video is such set of the heaters without the mirrors. It is obvious that the south must be there, and now I am showing the recommended tilt of the solar heaters for 50 degrees north latitude, if our season of operating the system is from April to September. The height of the interval between the heaters depends on the shadow from the upper heater, and this is the shadow in July. But then it rises, and now we see the shadows in October. It is obvious that the other geographic latitude and other season of operating require different recommendation for the tilt and the interval. If the equipment is located farther south than 45 degrees north latitude, it might be better to tilt the system this way. Otherwise, the heat production in summer months can decrease, also the remaining months of the year will not lose anything. If the solar heaters will not be used to heat a pool, increasing the heating temperature can be important. It is because traditional hot water supply requires that the hot water temperature be greater than 60 or 70 degrees Celsius. But this is not traditional hot water supply because its shower has only a tap from the hot water tank but does not have a tap for cold water. That is why the use of the shower becomes inconvenient if the temperature of the hot water is more than 40 degrees Celsius. Therefore, the solar heaters are operated without the transparent film or some other transparent coating. In addition, our hot water tank is not able to withstand high water pressure, and therefore we cannot use analogous idea when the cold water automatically goes to the tank if we take hot water from it. That is why the owner added cold water to the tank in the evening, watching this water temperature sensor and trying to lower the water temperature to a level of 40 degrees Celsius, and excess water leaves the tank through this hole. Now I am showing the connection points of the heaters with the tank, and we see that both connections are installed at the bottom of the tank, separately from each other and separately from this connection of the tank with the shower. This position of the connections allows operation of the system with half-empty tank or almost empty tank. Now I show my experiments with the first variant of connecting solar heaters with each other, and this bottle imitates our tank for hot water. Less warm water of the bottle goes down through this hose, and then the water goes up through the heaters, which heat it. Then the hot water comes back again in the bottle, and I remind you that this water circulation takes place without a pump. This phenomenon is sometimes called the term gravitational circulation of water. This phenomenon takes place if the tank is located higher than our solar heaters, and if all our pipes are filled with water without air accumulations. This is the second variant of connecting solar heaters with each other, and it is simpler than the first variant, but the speed of the water circulation is a little less. Here we can notice a slight slope of the heaters, and it is needed so that any air leaves their pipes. The hoses between the tank and the heaters must also have slopes, and I remind you that a large air bubble in the pipes of the heaters will stop the circulation of the water. These hoses must also have a downward slope. Such bends are very undesirable, because any gravity circulation of water requires minimal hydraulic resistance inside the heater pipes and inside other pipes or hoses of the system. In addition, the slopes may be needed to completely remove water from the system so that it does not freeze in winter, and for example now we stopped operating the system until the spring.